So in this lecture we are going to start differentiability. So in the last class we have been discussed about continuity and how to define, what is the actual meaning, how to solve questions related to continuity. I hope you all understood. So in this lecture we are going to start our next most beautiful topic, that is called differentiability. I know many of you had a stuck whenever you are seeing the questions, check whether it is a differentiable or not. So you people are suddenly struggling and you people are struggling to solve those type of questions, right? So let us make it easy. So as usual, the first question what we are going to consider is, here the given function is f of x equal to mod x, and we have to check whether this function is differentiable or not. How should I do this, sir? So here you know how to define f of x first, right? So because its limit is not given, so mod x can be rewritten as minus x when x is less than 0, and it will be plus x when x is greater than 0. Now it's time to solve this question. So let me define the first standard thing that you have to do. Find the left hand side derivative. While discussing about continuity, I was talking about left hand side limit, right hand side limit. Here we are going to talking about left hand side derivative, right hand side derivative, because we are talking about differentiability of a function. So for that we have to talk about the derivative only. So how should I define the derivative, sir? So numerically, while solving the problem, find the left hand side derivative with the help of limit. Let me define. X is approaching c only, but since we are traveling with the left hand side, so I have to put minus here. Then write f of x minus f of c, right? So let me clear it 1 second. Yeah, this is c, f of c upon x minus c. Some of you might be thinking, sir, what is this c, what is this x, everything. Don't worry, let me clear within few minutes. So the second one is, in the similar way you have to define the right hand side derivative also. That will be defined as limit x will be approaching c plus, this side I am putting plus. Why? Because we are traveling from right hand side. So this can be further defined as f of x minus f of c upon x minus c. Okay, sir. Sir, almost both formulas are looks similar, but here the difference is, let me show you that, let me tell you, the thing is, see there, in the left hand side limit, whatever the f of x that we are putting, you have to substitute the value of f of x which is given in your question for the correspondent x, that is x of less than c. Usually limits will be defined in our question. The value of c means that is specific point. So when the value of x is less than, f of x will be defined in your question for less than, for the limit, left hand side limit, you have to substitute that f of x value here. Similarly, in case of right hand side derivative, you have to substitute, replace this f of x by its correspondent value that is given for x greater than c. Don't forget this, that is very important. Shall we start now? Yes, sir, it's time to start. Here the point c is specifically defined. Here basically the value of c is actually 0. If you observe the question, it is clearly known. So here our point is what? 0 only. So when I was discussing about continuity, I used to take a. I was talking about a plus a minus. So here I am taking c plus, that's all. Don't think too much about it. Okay, sir. Now in order to solve both the left hand side derivative and the right hand side derivative, if you observe in both functions, it is must to know the value of f of c. So let me define the value of f of c first. F of c, what is the value of f of c? It is nothing but when the value of c is approaching to 0, basically c is nothing but x only. When the value of x is approaching to 0, let me redefine it clearly. When the value of x is approaching to 0, what is the value of f of x? That's all. Because we know the value of c is 0 only. So if I am putting 0, already we found the answer for this. The resultant answer will be 0 only, sir. So directly we can replace, in place of f of c you can put 0, and in place of c it is going to be 0 only. See, what is the value of c? C is 0. Here also the value of c is 0. Shall we start solving this question? Yes, sir. Let us take left hand side limit and try to bring the answer for this question. Left hand side limit means limit, I have to replace c. Here c will be treated as 0. 0 minus, we have to consider f of x minus f of c upon x minus c. How will you substitute the value here? from here I can define it further. Limit, since x is approaching 0 minus, whereas f of x means left hand side limit. When x is less than 0, what is the value of f of x? That is minus x. So I have to substitute minus x minus, what is the value of f of c? F of c is 0, sir, just now we found, divided by, what is the value of x minus, what is the value of c? Value of c is also 0, sir. So from here, if you carefully observe, what we are getting is minus x by x. Directly this term will be cancelling out and it will be giving as the answer as minus 1. Okay, sir. Now it's time to explore the value of left hand side derivative. Let us take, right hand side derivative. Do you know how to define the right side derivative? Right side derivative, once again, limit x is approaching 0 plus and the function is defined as f of x minus f of c upon x minus c. Undoubtedly, yes, sir. From here I can further define these points. Limit x is approaching to 0 plus, whereas f of x for right side limit. Go back to the question. Right side means when x is greater than 0, f of x is defined as plus x. So I have to substitute that value. It will be plus x minus f of c is already 0 upon x minus c, that is also 0. Now if you clearly observe here we are getting plus x by x only. So that will be equal to plus 1. After finding these two, you have to check whether the value of right hand side derivative and left hand side derivative are equal or not. If they are equal, then you can say yes, sir, the given function is differentiable, not continuous. I am writing wrong. So whether the function is differentiable or not? Yes, sir, this function is differentiable. Why? Because left hand side derivative and right hand side derivative are equal. Suppose if the right hand side derivative and left hand side derivative are not equal, then you can say no, sir, the given function is not differentiable. Now if you clearly observe our question, what we are getting here, minus 1 and plus 1, it clearly indicates that the given function right hand side derivative and right hand side left hand side derivative are not equal. So the given function is not differentiable. So what is the conclusion? Mod x, already we made the conclusion for mod x. Mod x is continuous, I hope you all remember, but it is not differentiable. Mod x is continuous, but it is not differentiable. Where? It is not differentiable at x equal to 0. If you observe clearly here, I am dealing with this function at x equal to 0 only. So here mod x is, it is continuous everywhere. This function is continuous everywhere, but it is not differentiable at x equal to 0. That is the answer for this question. Now let me bring the second question. You can take this question as the homework question and try to bring the answer. The question is f of x equal to mod of x plus 1. Is it differentiable or not? That is my question. You can take your own time and use your mastermind, try to bring the answer. This is all for this lecture. Remaining things we will see in the next class. Thank you all.